G'day everybody, it's Steve back again for another episode of Astronomy Daily. It is the 24th of June 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
So welcome aboard everybody, it's Steve here again. It's been a huge week in the sky again. We've got a star about to blow, a stranded spacecraft. Folks are still looking for the possibility of Planet 9, believe it or not. That's not all. A new satellite constellations are in development, and some are actually being deployed to aid in firefighting. China and France have launched a joint satellite mission for the very first time, and there's a family in the United States actually suing NASA over some space junk that hit their house. Ouch. I think the son was home at the time. That's not good. And how about this one? Using racing drones to test systems for controlling spacecraft. I think there was another craft recently that was controlled by a gaming controller, but that's not what we're talking about. We're talking about something a lot better than that. And if Hallie were here, she's not here today. Believe it or not, she's malfunctioned. So you've just got little old me today, a whole flesh and blood human being. So hopefully you'll be able to cope with that. So all of those stories that I mentioned before and a whole lot more are available on the latest and the previous editions and the upcoming editions of the Astronomy Daily newsletter. Now we will cover some of those stories on today's show, and I'll give you the details on how you can receive the newsletter in your email later on. And I would like to send out a huge hello to a new friend, Sean, who I met online the other night, and we had a little chat. Sean working in the space industry in, I believe it's Florida. Don't quote me on that one. But anyway, Sean, lovely to chat to the other night. Sean is someone who trains or has trained astronauts for the ISS at some stage of her career, and it was just fantastic to talk to her very briefly. She also plays guitar, and she says her husband can actually recognize the tunes that she's playing. So, winning on several levels. Thanks for joining us, and it's great if you're listening there, Sean. I promised I'd say hello. Anyway, on with the show. And here's a story we knew was going to turn up sooner or later. An American family is claiming more than $80,000 from NASA after a small piece of debris fell from space and smashed through the roof of their Florida home, a law firm said on Friday. The problem of space trash has risen in tandem with the increased spatial traffic, and NASA's response could set a precedent for how future claims are handled, law firm Cranfield Sumner said in a statement. On March 8, an object weighing just 700 grams hit Alejandro Otoro's home in Naples, Florida, making a hole in the roof. NASA later confirmed that it was, in fact, part of a cargo pallet used for batteries that was released from the International Space Station as waste in 2021, and instead of disintegrating before falling to Earth, a section remained intact when it re-entered the atmosphere, the US Space Agency said. Otoro's son was at home at the moment of impact, according to the law firm, which said that NASA now has 6 months to respond to its claim. My clients are seeking adequate compensation to account for the stress and impact that this event had on their lives, said lawyer Micah Nguyen-Worthy. They are grateful that no one sustained physical injuries from this incident, but a near-miss situation such as this could have been catastrophic. There could have been a serious injury or even a fatality. NASA did not immediately respond to requests for comment.
You're listening to Astronomy Daily, the podcast, with your host, Steve Dunkley.
French-Chinese satellite blasted off Saturday on a hunt for the mightiest explosions in the universe, in a notable example of cooperation between a Western power and an Asian giant. Developed by engineers from both countries, the Space Variable Objects Monitor, SVOM, is carrying 4 instruments, 2 French, 2 Chinese, that will seek out gamma-ray bursts, the light from which has travelled billions of light years to reach Earth. The 930 kilogram or 2,050 pound satellite successfully took off around 3 p.m. general mean time aboard the Chinese Long March 2C rocket from a space base in Zhejiang in southwest Sichuan Province, China, National Space Administration said. Gamma ray bursts usually occur after the explosion of huge stars, those more than 20 times as big as our Sun, or the fusion of compact stars. The extremely bright cosmic beams can give off a blast of energy equivalent to more than 1 billion suns. Observing them is like looking back in time, as the light from these objects takes a long time to reach us, or Gottlieb, an astrophysicist for Flatirons Institute Center for Astrophysics in New York, said. The rays carry traces of the gas clouds and galaxies they pass through on their journey through space, valuable data for better understanding the history and evolution of the universe. SVOM has the potential to unravel several mysteries in the field of gamma-ray bursts, including detecting the most distant GRBs in the universe, which correspond to the earliest GRBs. The most distant bursts identified to date were produced just 630 million years after the Big Bang, when the universe was in its infancy. We are interested in gamma-ray bursts for their own sake because they are very extreme cosmic explosions which allow us to better understand the death of certain stars, said Frédéric Diagny, an astrophysicist at the Paris Institute of Astrophysics. All of this data makes it possible to test the laws of physics with phenomena that are impossible to reproduce in a laboratory on Earth. The project stems from a partnership between French and Chinese space agencies, as well as other scientific and technical groups from both nations. US concerns on technology transfer have inhibited US allies from collaborating with the Chinese very much, but it does happen occasionally, said Jonathan McDowell, an astronomer at the Harvard-Smithsonian Center for Astrophysics in the United States. In 2018, China and France jointly launched CFO-SAT, an oceanographic satellite mainly used in marine meteorology. Several European countries have also taken part in China's Chang'e lunar exploration program, so while SVOM is by no means unique, it remains significant in the context of space collaboration between China and the West, said McDowell. Once in orbit, 625 kilometres or 388 miles above the Earth, the satellite will send its data back to observatories. The main challenge is that gamma-ray bursts are extremely brief, leaving scientists in a race against time to gather information. Once a gamma-ray burst is detected, SVOM will send an alert to a team on duty around the clock. Within 5 minutes, they will have to rev up a network of telescopes on the ground that will align precisely with the axis of the burst's source to make a detailed observation.
Astronomy Daily, the podcast.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at AstroDailyPod on X, or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there. NASA said on Friday the Boeing Starliner's return to Earth from the International Space Station, which is scheduled for next week, has been delayed once again. The delay of the rescheduled June 26 return will allow for more time for the review of the thruster malfunctions and helium leaks that caused the first delay, NASA said. Starliner's first crewed mission to the ISS, which had initially been scheduled to last about 8 days, has been extended to a date yet to be determined. The spaceship blasted off from Florida atop a United Launch Alliance Atlas V rocket on June 5 following years of delays and safety scares, as well as 2 aborted launch attempts that came as astronauts were strapped in and ready to go. NASA and Boeing and leadership are adjusting the return to Earth of the Starliner crew flight test spacecraft, NASA said in a blog post late on Friday. The move off Wednesday, June 26, deconflicts Starliner's undocking and landing from series of planned International Space Station spacewalks while allowing mission teams time to review propulsion systems data, it said. NASA's Commercial Crew Program Manager Steve Stitch said, "We are taking our time and following our standard mission management team process. We are letting the data drive our decision-making relative to managing the small helium system leaks and thruster performance we observed during rendezvous and docking," he said. NASA said the crew was not in a hurry to leave the space station because it is well stocked with supplies and the station's schedule is relatively open through mid-August. The initial ISS docking was delayed more than an hour after some of Starliner's thrusters that provide fine manoeuvring initially failed to kick in. It was known there was one helium leak affecting Starliner before the launch. While non-combustible, helium provides pressure to the propulsion system. However, other leaks emerged during the flight.
Astronomy Daily with Steve and Hallie. Space, space science, and astronomy.
Around the world this summer, professional and amateur astronomers alike will be fixed on one small constellation deep in the night sky. But it's not the 7 stars of Coronae Borealis, the Northern Crown, that have sparked such fascination. It's a dark spot among them where an impending nova event so bright it will be visible on Earth with the naked eye is poised to occur. This once-in-a-lifetime event will likely create a lot of new astronomers out there, giving young people a cosmic event they can observe for themselves. They'll ask a lot of questions and collect their own data, said Dr. Rebecca Hounsell, an assistant research scientist specialising in nova events at NASA's Goddard Space Flight Center in Greenbelt, Maryland. T Coronae Borealis, dubbed the Blaze Star, is a binary system nestled in the Northern Crown, some 3,000 light-years from Earth. The system is comprised of a white dwarf, an Earth-sized remnant of a dead star with a mass comparable to that of our Sun, and an ancient red giant slowly being stripped of the hydrogen by the relentless gravitational pull of its hungry neighbour. The hydrogen from the red giant accretes from the surface of the white dwarf, causing a build-up of pressure and heat. Eventually, it triggers a thermonuclear explosion big enough to blast away that accreted material, and that event appears to reoccur on average every 80 years. Don't confuse a nova with a supernova, a final titanic explosion that destroys some dying stars, Hansel said. In a nova event, the dwarf star remains intact, sending the accumulated material hurtling into space in a blinding flash. The cycle typically repeats itself over time, a process which can carry on for tens of hundreds or thousands of years. There are a few recurrent novae in very short cycles, but typically we don't often see a repeated outburst in human lifetime, and rarely one so relatively close to our own system, Hansel said. It's incredibly exciting to have this front row seat.
You're listening to Astronomy Daily, the podcast.
Drones are being raced at Delft University of Technology's Cyber Zoo to evaluate neural network-based AI control systems for future space missions. The research conducted by ESA's Advanced Concept Team and the Micro Air Vehicle Laboratory is detailed in the latest issue of Science Robotics. Through a long-term collaboration, we've been looking into the use of trainable neural networks for the autonomous oversight of all kinds of demanding spacecraft maneuvers, such as interplanetary transfers, surface landings, and dockings, said Dario Izzo, scientific coordinator of ESA's ACT. In space, every onboard resource must be utilised as efficiently as possible, including propellant, available energy, computing resources, and often time. Such a neural network approach could enable optimum onboard operations, boosting mission autonomy and robustness, but we needed a way to test it in the real world ahead of planning actual space missions. That's when we settle on drone racing as the ideal gym environment to test end-to-end neural architectures on real robotic platforms to increase confidence in their future use in space. Drones compete to achieve the best times through a set course within the Cyber Zoo at TU Delft, a 10 by 10 metre test area maintained by the university's Faculty of Aerospace Engineering. Human-steered micro-air vehicle quadcopters alternate with autonomous counterparts using neural networks trained in various ways. The traditional way that spacecraft manoeuvres work is that they are planned in detail on the ground and then uploaded to the spacecraft to be carried out, explained ACT young graduate trainee Sebastian Origa. Essentially, when it comes to mission guidance and control, the guidance part occurs on the ground while the control part is undertaken by the spacecraft. The space environment is unpredictable, with potential for unforeseen factors such as gravitational variations, atmospheric turbulence, and when a spacecraft deviates from its planned path, its control system works to return it to the set profile, which can be costly in resource terms. Sebastian added, "Our alternative end-to-end guidance and control networks approach involves all the work taking place on the spacecraft instead of sticking to a single set course. The spacecraft continually replans its optimal trajectory, starting from the current position it finds itself at, which proves to be much more efficient. In computer simulations, neural nets performed well when trained using behavioural cloning, based on exposure to expert examples. The researchers turned to drones to test this approach in the real world. There's quite a lot of synergies between drones and spacecraft, although the dynamics involved in flying drones are much faster and noisier," commented Dario. And that's about all I have for you today. Thanks for joining me. I'm sorry Hallie wasn't with us today. I'm sure when she gets her batteries sorted out or whatever it is that she needs to do, she'll be back with us again in the flight seat. Maybe I need to keep a set of jumper leads in the studio. And don't forget that Anna and Charlie will be with you on Wednesday and Friday. So look forward to that. And we'll see you next Monday. Bye for now.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
So we'll be back next Monday, and I hope you'll join Anna and Charlie on Wednesday and Friday for their presentations as well, bringing you more about astronomy, space science and science from all around the globe. But don't forget to go to our sites and check out the Astronomy Daily newsletter and sign up for that. Bye for now.